Hello everyone, this is Zahid Bashir. I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab, Lahore. In my previous session, I was discussing about the ARDL process, and we have used a data set, data for ARDL model, and I have discussed the process with with the step number 5, because the previous 4 steps I have discussed in detail, like optimal lag model, and I have concluded the step number 5, like co-integration test. Today, the participants could not join due to unavoidable circumstances. So I am continuing without any participation. I am recording this video on behalf of the participants so that I can share the recordings of this video with them. So, in my previous session, I have discussed the co-integration test. This test is basically used for testing the co-integration, or in the other terms, you can say we are interested in assessing the long-term relationship between the variables. So, in order to confirm whether a long-term relationship exists between the variables of interest, uh, we are going to consider the co-integration test. And in our previous session, we have find out some long-term relationships. I have told you that we can compare the F value as well as T value with their critical values. If the F values are greater than the lower bounds and upper bounds at all levels at 1%, 2.5%, 5%, and 10%, or the T value is greater than their critical T values at lower bounds and upper bounds at all levels, then we can conclude that there is a co-integration, or there is a long-term relationship between the variables. After confirming the long-term relationship, we uh, basically proceed with step number 6. After confirming the long-term co-integration between the variables of the study through bound test, you need to run ARDL command through the following procedure. Simple procedure is explained in the previous step. However, following are the more better command. So we are going to run this command. This is basically error correction command for running the ARDL with restore, and you can say you are going to confirm a robust result with this command. So this command will estimate the long run and short run relationship. So let us use this command. Simply, we may copy this command from here. We can put it here like this. We can replace the depth var with dependent variable, which is FDI, and we can replace the independent variable with our independent variable, for example, LU up and LFD, which are the log values of economic uncertainty and log value of financial development. Then EC stand for error correction, and rec store basically store the command, and loot rec is basically for you can say the robust estimates of ARDL. So we can run this command and you will see the results. Here are the results. You can see here the R square is 91%. The adjusted R square is approximately 77%. Number of observation are 16. You can see here the adjustment of your error correction. This basically particular row with adjustment of lag value of FDI is basically indicates a negative value. So whenever you apply the error correction, it will directly apply to the lag value of your dependent variable. And if it comes with the negative coefficient along with the significance value, then it means that your adjustment of error correction has been correctly estimated here. So this value should always be in the negative. It means whenever you apply the error correction model with ARDL, this will estimates this should estimates a negative coefficient with significance value. If this becomes if this value becomes the positive or it becomes the negative but insignificant, then you can say that error correction is not efficient here. But in our case, it is negative and significant, so we can interpret this value as a efficient error correction here. The second one is LR, which is basically the long run estimates of your ARDL. So you can see here that there is a weak negative impact of LUP. There is a weak negative long-term impact of LUP on your dependent variable FDI. The next is financial development. It is positive, but it is not significant. Here you can see the short run impact. Uh, the first lag difference of FDI, you can see it is positive and it is weakly significant. Then you can see here the log of EUP. It is not significant either at the first difference or the lag difference or the second lag difference. Then you can see here the financial development lag value. It is not significant at the first difference, but it is statistically significant and positive at the lag difference value. So it is the interpretation of these estimates. Then you can also apply another way of considering this regression. You just need to consider you can change the setting of your basic model with these. For example, here you can put dependent and independent variable here. We can replace here the dependent, independent, and then you can see here the AIC criteria, which is basically the lag length criteria. If you remember that we have an optimal lag criteria here that we have discussed in uh, 4 steps, that is the optimal lag selection criteria. So sometimes the researcher prefer that we automatically estimates the lag with AIC criteria uh, in the ARDL. So here, using this command, you can automatically consider the lag length based on AIC criteria. Then it is error correction, then reg store, and this is error correction regression estimates. So this is some a command with robust estimate. So you can see here again the R square is 91%. The adjusted R square is 77%. You can see the adjustment of your first lag of dependent variable is also negative and statistically significant. Previously, it was also significant and it was showing the same value. So it does not change with this command. You can see the long run estimates of LUP is also similar with the similar estimates. And you can see here the lag difference of FDI, which is your dependent variable, is also positive and statistically significant. Then you can see the similar results with LUP, LFD. You can estimate the similar result with this command and with this command. So it represents 2, 3, and 2. Here, the lag length. And again, it is showing the same optimal lag length here. So 2, 3, 2 means that your dependent variable was considered with second lag. Your first independent variable was considered with third lag. And your second independent variable was considered with the second lag. So this is the AIC criteria. So if you would like to consider the AIC criteria or the lag length with the AIC criteria, you can use this one. So after doing this, we can proceed with the next step. After applying the step number 6, which is ARDL estimation, Now you need to consider some diagnostic test, which is the step number 7. So let me, all right. So I was discussing some diagnostic test which you requires after applying the ARDL estimations. Uh, these diagnostic tests are important because if you check these diagnostic, or if you verify these diagnostic, it these are important for the validity of your ARDL estimates. It means there should be no serial correlation, there should be no heteroscedasticity, there should be no normality issue, there should be no functional form issue, there should be no specification error. So after giving the output of these diagnostic tests, your ARDL estimates would be considered valid. So let me introduce here these tests one by one. The first one is serial correlation by Bruce Godfrey Hallam test. So in order to apply the serial correlation or autocorrelation, we need to consider this step. You can run the OLS, or you can also run the ARDL. So in order to apply the serial correlation, first of all, you need to run a regression procedure. As we have done here the ARDL, ARDL is also a regression procedure. So we can proceed with the second step directly. In order to consider the second step, you need to write dw stat. So here I need to write dw stat, press enter, and it will indicate you some value. You need to see this value after the equal sign. You can see here this value is 2.12. It is close to 2. So what is the decision criteria? What we can consider, which value is favorable or which value is not favorable? So a value equal to or close to 2 indicates zero autocorrelation. So we can see here our value is close to 2. So we can consider there is no autocorrelation here. The second thing, if a value is greater than 2.5, it indicates a negative autocorrelation, and a value less than 1.5 indicates a positive autocorrelation. So if a value is in between 2.5 and 1.5, we can consider it as a close to 2. So it will indicate a zero autocorrelation. You can also apply another test, which is known as Bruce-Godfrey test. The previous test was basically the Durbin-Watson test. So both of these tests are used for serial correlation or autocorrelation estimation. So according to Durbin-Watson, there is no autocorrelation. We can also confirm the procedure with Bruce-Godfrey test. So in order to apply this criteria, you need to use this command. So we can run this command here like this. So it will indicate us a probability value. So the null hypothesis is no serial correlation. As this null hypothesis is not rejected here because the p-value is greater than 5%. If the p-value is less than 5%, then we need to reject this hypothesis. As the p-value is greater than 5%, so we cannot reject this hypothesis. So here we can conclude that there is no serial correlation here. So I have indicated here the decision criteria. If p-value is less than 5%, it means there is serial correlation here. If p-value is greater than 5%, it means there is no serial correlation. So here we conclude that according to the first assumption, there is no violation of serial correlation assumption here. So using this test, the ARDL estimation is validated here. Now we need to check the heteroscedasticity, Bruce, Pagan, Godfrey, or White test. So this is another assumption, or you can say this is the another diagnostic. that you need to apply. For applying this procedure, you can run the regression, you can run the ARDL, or you can run the simple OLS with this procedure. And as a second step, you need to run any one of the following tests. The first test is Bruce-Pagan-Godfrey test, and the second test is White test. So we need to run a fresh regression here. We can run it again because we have applied some diagnostic tests. So in order to apply another diagnostic, we need to run the regression again, a fresh regression. Then we can apply, first of all, the E-stat hat test, which is a Bruce-Pagan-Godfrey test for heteroscedasticity. So press enter, and it will indicate some p-value. This p-value is greater than 5%. So we can say there is no heteroscedasticity here. The decision criteria again is the same. If the p-value is less than 5%, it means heteroscedasticity is there. But if p-value is greater than 5%, it means there is no heteroscedasticity. So you can see here the p-value is greater than 5%. So we can conclude there is no heteroscedasticity here. The second test is White test. You can apply this test using IM test, comma, White. So this is basically the White test. This is also used for assessing the heteroscedasticity. It requires that you need to run a fresh regression here. So we can run the regression again. It is possible that you may run the OLS regression, but as I have already mentioned that ARDL is also a regression, so you can run the ARDL instead. So this is the White test. IM test is only possible after regress. All right, it means we need to run the OLS regression. So rec FDI LEUP LFT robust. Sorry, before it, you should not use the robust term because we are going to consider the heteroscedasticity, and robust term basically control the heteroscedasticity. So here you can see the p-value of White test. It is greater than 5%. You can also verify this p-value from here in front of heteroscedasticity. So this is greater than 5%. So we can say that there is no heteroscedasticity here, according to Bruce-Wagen and as well as according to White test. So here the second assumption is also not violated. So we can say the ARDL estimates is validated here according to both of these tests. Now we can consider the normality test using Jerk-Barra test. There are a lot of other criteria for normality, but this test is prominent among the research community for considering the normality. So we can consider the normality test using Jerk-Barra test. So here is the procedure you need to understand. In order to consider the normality, first of all, you need to run a simple regression here. So we can run here the simple regression like this. After doing it, we need to create an error term using the following command. So this is the command for creating an error term or residual term. So predict E residue. We can write here predict E, comma, RESID, resid. All right. So it will create a residual term here. So you can see here E term. You can also verify that the values with E terms were created here. So after doing this, what we need to do? You need to run the Jerk-Barra test. It is simply JBE with space between JBE. So you need to write here JB space E. So you can run it. If it is not recognized, you need to install JB. So SSC install JB. If it is run, you need to see the chi-square value. So this chi-square value is greater than 5%. So as this value is greater than 5%, we can say that it is normal distribution. But if the value is less than 5%, we can say this is not normal distribution. So chi-square here means the p-value. So p-value is greater than 5% here. So according to this criteria also, there is no violation of the third assumption here. So according to the first three assumptions, the ARDL estimates that we have considered in step number 6 are validated here. Now, the fourth step is functional form using Ramsey reset test. So how can we run the Ramsey reset test? So I need to show you uh, the Ramsey uh, test. It is also known as specification error test that we need to consider. Another command, sorry, this is not the Ramsey test. Yes, functional form using Ramsey reset test. So it is a test of whether the functional form of the regression is appropriate. In other words, we test whether the relationship between the dependent variable and independent variable really should be linear or whether a non-linear form would be more appropriate. So this test will indicate whether there is a linear relationship between IV and DV. So in order to apply this test, you need to run the OLS. Then you need to run the Ramsey Ries test using the following procedure. So this is basically the command, but at first you need to run the fresh regression. So we can run the fresh regression, and after running it, we need to consider E-stat OV test. So E-stat OV test. Now, you can see here the probability greater than F, it is also greater than 5%. So a value greater than 5% indicates that there is no issue of functional form or there is no omitted variable here. So we can conclude here, there is no issue of functional form of the model. So if the value becomes less than 5%, you can say there is an issue of functional form. So in that case, we also conclude that some important variables are omitted. But in our case, as the value is greater than 5%, so we can say that there is no issue of functional form. And in other words, there is no omitted variable issue here. So all the important variables are included in this model. The next one, if we see here, next one is the last one. That is the specification error test. So this is the fifth, basically the diagnostic test. According to the first four diagnostic tests, the ARDL estimates are validated. So according to this test, we need to verify whether the ARDL estimates are validated or not. So we need to consider this command. This is basically the link test command. It is also known as specification error test. So another command to test the model specification is link test. So first of all, you need to understand how can we verify using this command whether the assumption is violated or not. So it checks whether we need more variable in our model by running a new regression with the observed dependent variable against y hat, which is the predicted value of your dependent variable, and y hat square as an independent variable. So what you need to do, the software will automatically calculate a predicted dependent variable and a predicted squared dependent variable as a independent variable in order to check whether there is a specification error here or not. So the null hypothesis is that there is no specification error if the p-value of hat square, this is the important thing, If the p-value of hat square is not significant, then we fail to reject the null hypothesis and conclude that our model is correctly specified. So what we need to consider here, that the p-value should not be significant, or p-value should be greater than 5%. If the p-value is greater than 5%, we can say that the model is not misspecified or there is no specification error here. So the same criteria that we have previously used. So first of all, we need to run the fresh regression here. After running the fresh regression, we need to write here link test, and it will show us another regression. Here we need to see the hat square results. So we need to focus on hat square. You need to see the p-value of hat square. Here you can see the p-value of hat square is not significant. It is greater than 5%. So the criteria is, if the p-value of hat square is greater than 5%, we can say that the model is not misspecified or there is no specification error here. So what we have concluded? We have concluded here that all of these diagnostics have verified that the ARDL estimates that we have run in the step number 6 are validated here. So these diagnostic indicates that the results of our ARDL estimates are valid and efficient. So there is no violation of these assumptions, or there is no violation according to these steps. So what we have concluded, you can see here the results of your ARDL that we have concluded here. So these were the results of your ARDL. So these results are valid here. These estimates are valid. These estimates are efficient. So we don't need to worry about anything because our diagnostics are verified here. So this is all about the ARDL estimates. And today's the participants could not join, but on behalf of them, I have recorded this session. And with this, we have covered the ARDL model, the OLS model. And in the next session, we will consider if variables are not, if the variables are co-integrated, then how can we use the VECM? And if they are not co-integrated, how can we use the VAR model? And how can we consider the autoregressive model? So thank you very much for joining, and stay blessed, and let's meet in the next session. So thank you very much.